Hey guys, here is example number 4. This is actually the example part, not at the end. This is the one with the airplane. Okay, so I just copied the basic picture. You guys can fill in most of the blanks, but I think what people were having trouble with was they just sort of say, solve right triangle CBA and find out that angle BCA is such and such. So they don't really explain where that came from. So I'm just going to help with that little part of it. They're basically looking for this angle, which is the same as this angle. It doesn't really matter which one you do, but this is what they want, one of those two. So let's call it X. Okay, again, they're both the same. It doesn't really matter. And then what I want you to do is just focus your eyes on one of the triangles. Okay, so let's just look at this one. What kind of triangle do we actually have here? Okay, you've got a tangent, a radius, and then this segment here. Well, if you've got a tangent to the circle and the radius drawn to that point, well then there's your right angle. Okay, the tangent is always perpendicular to the radius of a circle at the point of tangency. So let's just kind of pull that triangle out and label what we know. So I'll make a new picture where I have a right angle here, and let's see, that's a really bad picture. Hang on, let's do a better picture here. There we go. That's much gooder. Alright, so here's D, here's C, here's A. Again, I'm pulling it right from here. C, D, A. I have my right angle. I have my right angle. I have 4,000, which is here. So this is 4,000. And I have 4,005, which is this one. So this is 4,005. And I'm looking for this angle here. There's my X. Now this needs to look very familiar. This is why we did this in the last unit. This is, if you hopefully remember and you're looking at this saying, oh yeah, I got this. But if you still don't remember, this is our trig ratios, right? We're looking for this angle. We know the side that's opposite. We're trying to, we also know the hypotenuse. Sorry. We know the hypotenuse. So we're going to be using opposite with hypotenuse. So hopefully you remember your SOHCAHTOA trick, or however you remember it, but this looks like a sine problem. So the sine of the angle is equal to opposite divided by hypotenuse. And if you don't remember how to go backwards, you could look that up, but this is going to be our inverse. So if sine of x is this ratio, then inverse sine of this ratio must be x. So inverse sine of this ratio, whatever that is in the calculator, must equal x. And that's where they got it from. Okay, I don't actually have my thing handy, so I'm not going to look that up, but you guys can check it out. I also have the answer key on Edmodo. But if you do the inverse sine of opposite over hypotenuse, you will get that x value. And then from there, you can follow the steps from the one from the book. Okay, hopefully that helps. Again, let me know if you need anything else, and we'll talk to you guys later.